In this educating video, I want to go over how we can use and implement grouping to factor a quadratic expression like this one. Now, I'm pretty sure that you guys covered factoring with Miss Tracy, and she probably showed you a different technique than this, because I'm not sure if she actually covered grouping earlier, but either way, we've covered grouping, and now we're going to use a different strategy to factor quadratic expressions like this one. Now, let's just go and look at this. I've got the step-by-step procedure on your in-class assignment written out. And the very first step says, Step 1, write the quadratic in standard form, and then identify A, B, and C. So recall that standard form of a quadratic looks like this expression. Some number A times x squared plus some number B times x plus C is equal to 0. So the first thing you should ask yourself, is this equation that we have in number 1, is it in standard form? And the answer is absolutely not. It is not in standard form. So the very first thing that we have to do is we have to add 4. Yes, let's do this. Let's just rewrite the expression down here. X squared plus 5x is equal to negative 4. And then, of course, we need to add 4 to both sides to rewrite it in standard form. And we end up getting x squared plus 5x. And the 4 can't be combined with anything on this side, so we just put the plus 4 on the end. And then, of course, negative 4 plus 4 just goes to 0, and we have 0. Now our expression that we're trying to factor is in standard form. X squared plus 5x plus 4 is equal to 0. Now identify A, B, and C. Go ahead. What do you think A, B, and C are? Yeah, so hopefully you were able to say that if we look at our general form of a quadratic in standard form, we see that the A is the number directly in front of x squared. That is the coefficient of the x squared term. So here, it doesn't look like there's a number out there, but you guys know that there's always a hidden 1 in front of x squared. So we would say in this case that A is equal to 1. And then we've got, see here, okay, we want to identify our B. We see B is the coefficient of x. So we look down here, here's our x, and the coefficient of x is the number 5. So we say B is equal to 5. And then we say, what is our only term that doesn't have a variable attached to it? That's going to be our C. And in this case, it's just going to be 4. That is the constant in our expression. So we say C is 4. And now that we've identified our A, our B, and our C, we can go on to the second step, which is very simple. It just says multiply A and C together. Now if we go back, we know that our A is 1 and our C is 4. So we just go over here and we write 1 times positive 4. Now just make sure that you keep the sign with it. So this is a positive 4. If it were a negative 4, we'd need to do 1 times negative 4. But luckily, here in our first example, we're only dealing with positive numbers. So we've got 1 times 4, and that's going to be equal to 4. Equal to 4. And that's all there is on step number 2. Now step number 3 says find two numbers which multiply to produce the number in step 2, but add to produce B. Now let's just write here. B, just recall, B on the previous slide was 5. So B was equal to 5. Now we want to find two numbers that we can multiply together to produce the number in step 2, that is 4, but add to produce B, which is 5, and we need to be careful with our signs. Okay, so the way that I typically do this is I just set up a t-chart, and I put the product of A and C at the top of my t-chart. So up here I'm going to put 4. There's my 4. And I just list all the numbers that can be multiplied together to give me that number 4. And I usually just start with 1 and the number that I'm trying to get. So 1 and 4. Now we can do 2 and 2. And that's it for this expression. We know 3 won't go into 4, and we've already got 4 times 1. So those are the only numbers that I can multiply together to get 4. Now, which pair can be combined, that is, added or subtracted in some way to get B? What do you think? Yeah, so hopefully you were able to say that it's the 1 and the 4 that we need to combine in some way to get this 5. But it's not just combined, but we need a positive 1. We need a positive 1 and a positive 4 to combine to get the 5. So I just double check that the conditions have been met. So 1 times 4, obviously that'll give me 4, and then 4 plus 1 will give me 5. So which pair can be combined to get B? We're going to say positive 1 and positive 4. Now sometimes these numbers, you'll have to correct for the signs. That's why I say be careful with your signs, because sometimes this 1 may have to be negative, sometimes the 4 will have to be negative, all depending on what B is equal to and what the product of A and C are. But in this case, positive 1 times positive 4 gives me the 4, and then positive 4 plus 1 gives me 5. So we're good to go, and we can continue on to step number 4. So step number 4 says, rewrite the quadratic, but replace the middle term with 2 terms using the 2 numbers from step 3. Now, this is the point where if you factored quadratics with Miss Tracy, it's going to be different here. Now, both methods work, but this is the method that we're covering in the standard. I'm just showing you a new way and a new technique that you can use to factor quadratics. So I'm just going to rewrite our original quadratic at the top. So remember that our original quadratic here in standard form was x squared plus 5x plus 4. And I'm just going to rewrite that up at the top. X squared plus 5x and then plus 4 is all equal to 0. So I just rewrote the quadratic up here just that way we can see it. But now we want to replace the middle term with the two terms using the 2 numbers from step 3. That's why down here in the blanks I have 4 blanks instead of just 3 now, because now we want to split this 5x into 2 terms using the positive 1 and positive 4 from the previous slide. So what that means is I'll do positive 1, and I've already got my positive here, so you don't have to rewrite the positive, so plus, and then we'll do 4 there. Now, we want to rewrite this term using those 2 numbers, okay? But positive 1 plus 4 is equal to 5. It's not equal to 5x. So we need to do positive 1x and then plus 4x. And you can see that if I were to combine these two, 1x plus 4x would give me the 5x. That's what I mean by replacing the middle term with 2 terms using the 2 numbers from step 3. So we've taken this 5x, which is 1 term, and we've split it into 2. Now the first blank, we haven't done anything with the x squared, so we just bring it straight down, x squared, and we haven't done anything with our 4, so we just bring it straight down as well. So plus 4 here. Okay, now we want to use the grouping technique to factor this expression. So watch this because it gets kind of neat here. So x squared plus 1x plus 4x plus 4. Let's group 2 terms, or let's group these terms together and then factor and factor again until the expression cannot be factored anymore. And I've already have this written down on step number 5. So use the grouping technique to factor the expression. Now you can see that I have grouped using my parentheses the first 2 terms together, and I've also factored the last 2 terms together using these parentheses. Now I ask myself, what is the greatest common factor of the first group? Yeah, so hopefully you were able to say that the greatest common factor of this first group is x. So if I want to factor out an x from this expression, that is, write it outside the parentheses, then I need to put the x outside the parentheses first. So I put my x down outside the parentheses, and I ask myself, what is the first term inside the parentheses after I factor out the greatest common factor? Yeah, so the very first term is just going to be x. Just going to be x, because if I were to divide x squared by x, I'll write this off to the side, x squared divided by x is equal to just x. 2 minus 1, which is just x. So we know that the very first term will be x. And then, of course, plus, we bring the plus down. And what do you guys think the second term in my first group is going to be? And hopefully you were able to say that we're just going to have a 1 left over here. Okay, because the reason is because I take my original expression, 1x, and I divide it by whatever it is that I'm factoring out, which in this case is the greatest common factor. And if I do, I'll just write this at the top, if I do 1x divided by x, that's just equal to, because my x's cancel out, that's just equal to 1 there. Oops, wrong color. Let's do 1 there. Okay, so go ahead. Let's continue this problem. What do you think is the greatest common factor of my second group? And hopefully you're getting pretty good at this. You would say 4. So we want to factor out a 4 from this second group. So when I pull out this 4 outside the parentheses, that's why I have this blank down here. I'm pulling the 4 out, that is factoring the 4 out from the second group. I write it outside the parentheses. Now, what do you think the first term inside the second group should be? Yeah, hopefully you were able to say that it's just going to be x. Now, I'm not going to write down the side work because I think you are seeing at this point where I'm getting this. So I just do 4x divided by 4. That gives me x. And what do you think the second term is going to be? Yeah, so the second term inside my parentheses here, and inside my second group, is going to be the 4 divided by 4, because that's what I'm factoring out. I have to divide every single term by the number or variable or combination of a number and a variable that I'm factoring out. So 4 divided by 4, they're both positive, so I get a positive 1 here. Now remember, we're not done yet. We need to keep factoring this until we only have a single term that contains only factors. So right now we have 2 terms. We have 1 term here, then plus our second term. But look at this, how cool is this? By grouping, you can see that an x plus 1 showed up in both terms. So if the x plus 1 showed up in both terms, that means I can factor out the x plus 1 from this entire expression. So maybe I can do this. Let's put some big yellow parentheses around this entire left-hand side of the expression. And I'll go down here and I'll put the yellow parentheses again. Okay, so I want to pull this x plus 1 outside the yellow parentheses. That is, I want to put them right outside here. So x plus 1, I'm factoring it out. So x plus 1 outside the yellow parentheses. Now, what's left? After I pull this x plus 1 out, that is, factor out the x plus 1. So yeah, we can factor out a binomial. So up here we were factoring out a monomial, that is just an x or a 4, but now I'm pulling out a factor that consists of 2 terms, and we call those binomials. So I can factor out this x plus 1, pull out the x plus 1. Now, we do the exact same procedure. Divide this entire term by x plus 1, and what you find is that your x plus 1's cancel out, and you're just left with an x as your first term. And then plus, okay, same thing over here. I'm factoring out the x plus 1, and when I do that, this entire term divided by x plus 1 leaves me with just a 4 here, and then equal to 0. Now I'm just going to rewrite this as x plus 1 times x plus 4 equals 0. So now I gotta be honest, when I did this example for my other classes, when I factored out this binomial, they look like this.
Do you want my head to explode? In the name of all that is good and decent, no more for today!
But hopefully for you guys, it wasn't that complicated. But since my other classes really struggled with this whole idea of pulling out this x plus 1, that is factoring out the x plus 1, I am gonna go ahead and stop there. So there's not gonna be any more for the day. Now there is another step that we could do here to actually solve for our x's, but I'm not going to make you do that. Let's just spend the day factoring, so that way your heads don't explode, which I don't think that they would, because you guys are incredible. But let's just stop there. This is my final answer. This is the fully factored version of my original expression, which was x squared plus 5x equals negative 4, except now you can see that we only have 1 term on the left-hand side that consists of 2 factors. So the x plus 1 is our first factor, and the x plus 4 is our second factor. All right, guys, just have fun practicing these. Keep going through the entire in-class assignment, and just let me know if you have any questions about this problem. Thanks.